To start today, I want you to try and come up with 3 advantages and 3 disadvantages for using stem and leaf diagrams to display data, based on what we've done in previous lessons. Okay, let's first of all look at some advantages. So, they're a concise representation of data. Concise means that they contain all of the data that you have, like all the information, you don't miss any out. However, they do so in the briefest sort of possible way. So you're not just like writing the list out, it's more concise than that. Okay, they contain raw data, that's linked to it really. You might argue that they're the same sort of thing. And then they show the range, minimum, maximum, gaps and clusters and outliers easily. Okay, we didn't really talk about that to be fair, but yeah, if you've got gaps, you can see them more easily than you just had a list of data. The disadvantages then are that they're not visually appealing. Well, do you know what? I think this is down to the individual. I actually really think they are quite nice. I suppose this is in comparison to other sort of charts with color and everything. But yeah, this is one thing that's deemed anyway. They're not as visually appealing as other types of graphs. They don't easily indicate measures of centrality for large data sets, i.e. they don't easily tell you where the mean, mode, median is, where some other ones do, such as box plots, but you know, they've got their own disadvantages, but yeah, that's one thing. And they're going to be messy and complicated for large samples. So if you've got loads of data, it's not going to be able to get much out of looking at a stem and leaf graph. Okay, so one thing we're going to look at today, when you get large samples and varied data, lots of different values, is to look at a histogram. And these are used for continuous data only, not for discrete. So they're a bit like a bar chart, but for continuous data. And there's one other thing that's absolutely crucial that we need to talk about. So if we look at this group data here, you can see stem and leaf, you know, if you did know the raw data, it would at this point be quite messy. Maybe we don't even know all our raw data. In any case, we can use a histogram to represent it. Now, why is this diagram misleading? What's going on? I'm plotting the time taken against the frequency. There's nothing actually incorrect about what I've drawn, but what is bad, like statistically, in terms of, well, maybe that's not very good phrasing, but what is misleading, and how could we change and improve it? Okay, the reason it's misleading is it looks like this is massive. It's taken up the majority of the area. But it's because we've got such a wide interval at this very end, 30 to 60. So there's only 15 people, you know, and when we look at the 5 to 10, there were 25 people, but this looks definitely more dominating, I'd say, than this orange one. So how can we change and improve it? Well, we can take the width into account. And in fact, we divide by the width. And that gives us something known as the frequency density, which is what we look at when we're going to draw a histogram. So let's have a go at drawing one. If you have no gaps, if you have exactly the same interval, by the way, then yes, you can just plot the frequency. That's okay. So histograms really come into their own when you have different widths. Okay, more on this in a second. So time taken to get to school. Here's another table. Right, I'm going to work out the frequency density. I'm assuming you've seen this before, so this is a recap really of histograms and why we look at the frequency density. We're going to get onto more challenging topics and aspects in a second. Okay, but let's just give it a go and recap first of all. So the width in this case, because that is something we're going to need to be careful about in a bit. The width is it's 0 to 5. It's just 5. Yes, I know it can't actually equal 5. But it is essentially 5, or 4.9 recurring, which is 5. And then here, we got a width of 5 again. Then we got a width of 10. Then a width of 10. Then a width of 30. The frequency density, is frequency divided by width. Okay, worth writing that down. I think you would have seen that before. So in this case, it's going to be, okay, we've just got to make sure we do it the right way around. It's going to be 10 divided by 5, 2. This is going to be 5, 1.5, 1, and then finally 0.5. Okay, so we can then plot that. We can plot, it's going to be, I think it was time, wasn't it? Time in minutes. We should always label our axes. Against the frequency density, which is technically frequency per unit width. Okay, so I've got a little graph. It goes 5 is the maximum. So if we think about it, if we make this 1, 2, 3, 4, 5, that looks good. Perfect. And we're going up to 60. So 10, 20, 30, 40, 50, 60. That makes sense. Okay, you should be trying this as well, and maybe you've paused the video, you're doing it, and then you're just going to fast forward and check that your answer's the same. That's fine. Okay, brilliant. So 0 to 5 is 10. Sorry, is frequency density of 2. Five to 10 is 5. Then it's 1.5, 10 to 20. Then 1. And finally 0.5. And we've sorted this one out. This one thought it was cool, it was amazing, it was taken over like we saw here, but actually when we divide by the width, suddenly it's put in its place. It's actually not that big because we've got such a wide interval. We're taking into account the frequency. Okay, we can obviously we can make this colorful, and we get quite an appealing picture to look at and do calculations from, because if frequency density is frequency divided by width, then we can rearrange that. Frequency is going to be frequency density times the width, and now the areas of the bars represent the frequency, so we can really see that, yeah, this one is is the biggest and is kind of taken over now, and that's going to be something we use in more detail in a minute. Okay, let's carry on with our histograms. So in histograms, the area is proportional to the frequency. A minute ago, I said it was the same, and it is the same in the sort of units that you're measuring in. But if you suddenly start measuring in centimeters squared, for example, then there's going to be a constant proportionality to go from your frequency and the area that you kind of think it is in terms of the frequency density to something in centimeters squared or whatever. So just be aware of that. There are no gaps between bars because it's continuous data. Yeah, whereas in a bar chart we showed that we had gaps in between. I think I've been talking about this already. And that's just a summary. To be honest, I've already smashed it and told you all that stuff. Okay. Sometimes we get histograms that are a bit incomplete. So let's have a look at this now. And I do see this. I see this. This is probably the most likely scenario that will come up in A-level. Essentially, we're told the frequency for one of the bars, and then we have to fill in everything else. And there are gaps along the vertical axis. We don't know how it's labeled. We've got to try and figure out what's going on. So essentially, we're told that there are 50 people with heights between 24 and 26. So as before, I'm going to put width in and frequency density. So the width is going to be 2, 1, 1, 3, and 6. So the frequency density is going to be 25, 60, and 40. And we can use that to help label things. 5, 10, 15. Oh yeah, good. So it's going up in, we can see now it's going up in 5s. That's going to be 10. That's going to be 20. I get my 25. That's going to be 40. Actually, I think I've rushed that a little bit. I got away with it, but really, I've just this is the one I focused on because I've got information on that one. Okay, so I'm basically reading off that this is 25, so it must be going up in 5s. Okay, label it as frequency density. That was a 6. Brilliant. So we've dealt with that one. Okay, next one. Actually, we need to read off that their frequency density is 50. And therefore, we then multiply these two together to give us this frequency. So we're just filling in little gaps of information. And I can read off this one as well. This was the frequency density of 20. So it's going to have a frequency of 120. And then I can draw the other bars. So this one is at 50. Oh no, I already had that. This one's at next one's at 60, 27 to 28. Whoops. Okay, and then we have 40. Okay, and that is our completed histogram. We've completed the table and we've completed the histogram apart from shading it in. Let's have a bit of blue. Okay, done. Calculate an estimate of the number of heights which are between 29 and 32. Okay, for this, 29 and 32, we need to think carefully. It's going to be the area from here to here. So let me shade that in green. I'm now interested in this. By the way, it also must be that the total area is the total frequency, which I could work out because I've actually got it. But if I didn't have that information, and I knew that, I knew that I could maybe use that in some way as well. Okay, I don't actually need to do that here. All right, so if I want to work out this area, let's just do the left-hand area to start with. Then the width is equal to 2. And the height is equal to 40. So I'm getting 80 from that bit. And then this little bit, I know it's all in green, but hopefully this is clear enough, is going to be 1 times 20. Which is obviously 20. Nice one. So calculate an estimate. It's going to be 100. 80 plus 20. Now, just a reminder, it is an estimate because we have grouped data. We do not have the raw data, so we don't know how the data is spread within this. We've just sort of assumed it's spread evenly, and that's why we've drawn these horizontal lines. If I was asked for an estimate for the percentage of people between 29 and 32, okay, just throwing this one in there, then it would be 100 divided by the total frequency. Okay, I'll race you to work this one out. Oh, he's only gone and done it, so it's 400. Then I times it by 100. I'm going to get 25%. Okay, last thing I'm going to do, this is a topic that is on some GCSE syllabuses and not on others. It's not actually on the OCR syllabus at present. And it's to draw a frequency diagram or maybe use frequency polygon or use a frequency polygon. And I'm only really going to touch upon it here because you don't tend to see it come up, but I should just talk about it. A frequency polygon is when you join the midpoints of your histogram at top together. So there we go, that's our frequency polygon. Just be aware that if you were given a frequency polygon, then you could draw the histogram from it and you could use it. Remember, it's the midpoint, not like a starting point. I remember I made that mistake at one point when I was doing it. So just make a little note of that and have it in the back of your mind. You're much more likely to get asked a question like this about the histogram. And why do we care about frequency polygons? They're a graphical form of representation. Actually, you know what? I did copy and paste this, I've got to admit, because I don't think I'd phrase it quite the same. But it tells you about the shape of a graph, depicts trends, and it's more easy to make comparisons. So when I've got two frequency polygons, it's a bit easier to compare these two than having two histograms on top of one another. So I might be interested in the weights of cattle in two different herds, and I might have groups data, and I could draw a frequency polygon to give me a good idea of what's going on. So, you know, I could say that herd B has got a larger number of cattle at a lower weight, and then they're comparable at the higher weights, in fact, something like that. In this case, note we plotted frequency, and that's because all the groups are the same width, so we don't need to work out the frequency density. So just be aware of that. That is something that's useful to know. Okay, we've revised histograms. Hopefully that was useful. We've spoken about how you make them, why you make them as you do. We've spoken about if you have some information, how you fill in some of the other gaps. And then also chucked in a bit about frequency polygons. So all good stuff. Now we're going to go into the next level aspect of histograms. Okay, it's not as if it's loads more difficult. It's just the sneaky bit about histograms. So when we have histograms, we're looking at grouped data in different classes, and what we're interested in is definitely the class width. Sometimes we'll definitely be interested in the midpoint. So to get the class width and the midpoint, in fact, we're going to need the lower class boundary and the upper class boundary. So what are these things? Well, the lower class boundary, I mean, they kind of are exactly as they say. Lower class boundary is the smallest value that can be put into the class. And the upper class boundary, funnily enough, is the biggest. And then the width is going to be these subtracted, and the midpoint is going to be these added and divided by 2. That gives you the midpoints. Okay, so let's have a look at some different scenarios, because this is where it gets just a little bit tricky at times. Okay, and you might want to pause the video and have a think about this. What do you think the lower class boundary and the upper class boundary are for these ones that have highlighted in yellow? Okay, once you've got the lower class boundary and the upper class boundary, to be honest, the other two follow, so I'm not going to focus on that. Here, the lower class boundary is equal to 30 because that's the smallest value that it can take. And the upper class boundary, well, I know it can't equal 40 exactly. Yeah, it's always less than 40. So I'm not really quite happy with that because the upper class boundary we would write as 40. We can get as close to 40 as we want. 39.9999999. It's a bit like when you do lower and upper bounds earlier on in school. So that's how we do it, okay? Right, next one. Length of 30 leaves to the nearest centimetre. Okay, we're writing it in a slightly different way here. What do you think it is? Well, we're rounding to the nearest centimetre, so this is exactly your lower and upper bounds from earlier on in school. The lower class boundary is going to be 14.5. If it equaled that, it would round up to be in this to 15, and the upper class boundary, whilst it can't actually equal it, it can equal anything less than it. It's going to be 19.5. Be careful then in future, because if I want I think I will talk about the width of this one. Okay, the width, when you first look at this kind of question, you're like, oh yeah, it's 4, obviously, but look at it, no. The width is actually 5. So when you see a histogram, watch out for this, basically. If you've got an inequality, it's all good. If not, look at the intervals you're interested in and think about it carefully before you jump in and use the wrong width. Okay, sorry, I just got a bit carried away there, but I've seen it happen so many times. Right, mass of 40 packages. I did talk about this with grouped data before, how this could be written. This is quite a standard approach for mailing. I think this is definitely the right one. In the UK, we go 100 and 250. Not sure about that 800. But what this means is it means between 100 and 250 inclusive. So the lower class boundary is going to be 100. Okay, it can. If it was exactly 100, you might get away with posting it at that, but we still call that the lower class boundary. And the upper class boundary is going to be 250. And this one here is going to be anything between 0 and 100. So I hope you're happy with that. And then you can work out the width, okay? All right, and then finally, ages of applicants for a job in whole years. Right, we need to be careful now because we're not rounding up. If you are 24 years and 11 months and just shy of your birthday, then you're still 24 years old in whole years. So now the lower class boundary is going to be, for this yellow one, 25. And the upper class boundary is going to be 29. Again, can't equal 29, but it is still the upper class boundary. Whew, okay, sneaky, I told you so. All right, I'm going to test you on a few of these now. Right, they're gone. I just gave some spoilers away. Okay, what about these ones in green that I'm about to highlight? Can you write down the lower class boundary and the upper class boundary? Let's do this one here. Let's do that one. Oh, actually, I changed my mind. This one's too easy. How about this one? And then we'll go with, I already told you about that one, but let's do it anyway, just in case you weren't paying attention. And then I think I'll do this one here. Okay, pause the video, give these a go. All right, now I did talk previously about this one. When you don't have anything, an upper bound in here, what you actually do is you make it twice as much as the previous width. So if the width is 20, the width of this one is going to be 40. The lower class boundary is 80. And the upper class boundary is 120. Okay, be aware of that. I think that's quite unlikely to happen in an A-level exam, but it doesn't hurt to be aware of it. That's just a convention as well that's been decided by somebody. Okay, next one. I think this is the one that's the most likely to come up in A-level along with the first one, as in one of these. Okay, because I'll just be testing you on your understanding of this. So the lower class boundary, I'm not going to write down it now, I'm just going to write the figure down. It's going to be 24.5, and the upper class boundary is going to be 29.5. Okay, this one is going to be 0 and 100. And this last one is going to be 21 and 25. So I hope you are happy with this. I'm not going to test you on it anymore for the time being. Those are our boundaries. Okay, I did talk about this previously. It's usual to choose between 5 and 10 classes when grouping data. I said, like, if you don't have enough, you don't really get a feel for what's going on with the data. If you have like 100 classes, again, there's just too much going on. So 5 to 10 is just a good shout if you were ever to make group frequency tables yourself, or if you're asked about them. Oh, maybe I didn't. Sorry, I thought I'd already told you about this, but maybe I didn't. So sorry about that. I think I must have had a dream that I taught you this lesson, because yeah. So now you know anyway. Whenever you get a greater than or equal to, you basically make it twice the previous class. Be aware of that. Okay, this next bit is the last bit we're going to cover on histograms for the time being. It's the Sneakmaster 2000 part, because it requires you to understand what I just talked about a minute ago, and then just asks a bit on proportion as well. And if you're not ready for this sort of question, I think it can be quite tough, even if you think, yep, I know all there is to know about histograms. So we are told we're creating a histogram, and we've got a group 3 to 5 hours. It's represented by a rectangle. Let's have another go at that. Okay, so I've got my axes, I've got my rectangle. This is 3 to 5. And it's 1.5 centimeters high. Sorry, wide, and 12 centimeters high. I'm then interested in a different part of the histogram, the 11 to 15. And I don't know how wide this one is, and I don't know how high it is, and I want to figure those out. All right, well, first things first, we need to relate the centimeters to the actual width in hours. So I'm going to just add some columns to my histogram. First of all, the width then. The width is not equal to 2, and I'm sure you're thinking, yeah, I knew that, because look, it's been rounded. Whoops, I got rid of it. It's been rounded to the nearest hour. So this is actually 2.5 to 5.5, and the width is 3 hours. The other one is 11 to 15, so it's 10.5 as the lower bound, 15.5. This width is equal to 5. And actually, it might be best to just jump straight into that. So this is going to be 3, and this is going to be 5. So we can work out that 1 centimeter for the width is equal to 2 hours by dividing through by 1.5. And therefore, to go from hours to centimeters, I divide by 2. So the width is going to equal 5 divided by 2, or 2.5 centimeters. And I've worked out my first answer. I hope that makes sense. I've related the centimeters to the actual width. I've got it as a slightly better proportion, 1 centimeter to 2 hours, and then I've got 5 hours, so I've divided through by 2 to get the number of centimeters. Brilliant. Right, next one then. Okay, for this I need to use the frequency density, because that's the height that I'm interested in. So the frequency density is 24 divided by 3, which is going to be 8, and 30 divided by 5, which is 6. So I've got 12 centimeters, and that is worth a frequency density of 8, and h centimeters, which is worth 6. So again, what can we do? We can this time work out the number, like what 1 centimeter is worth. 1 centimeter is going to be worth 8 over 12. Or maybe I shouldn't do that. I should work out what 1 unit is worth. 1 unit is equal to 12 over 8 centimeters. Because now it's going to be 6 times 12 over 8. Okay, to get the number of centimeters. And that is equal to 9. I don't know why I did that with a calculator, but I thought it was going to be more complicated. Okay, 9. So the height of the rectangle is going to be 9 centimeters. Okay, brilliant. over to you. Here's a very similar sort of question where we're given some information. Pause the video, see if you can work out the width and the height of the 16 to 18 class. Alrighty, I'm going to go through it. It's going to be a very similar sort of process. I'm going to draw my first histogram that I know a bit about, the 10 to 15 one. And I'm going to draw my other one over here, the one I want to find out about, 16 to 18. I know that I've got a width of 2 centimeters and a height of 5 centimeters. And then I want to work out what this height is and what this width is. So how am I going to do that? Well, again, let's do similar to before. The width is going to, again, it's the nearest whole number, so 9.5 to 15.5, it's going to be 6. And for 16 to 18, it's going to be 3. So this is a width of 6, and I can see that 1 centimeter equals 3. So it's going to be 3. It's going to be 3 divided by 3. Sorry, so the width is going to be, I don't know why it took so long to figure that out. It's just like, it's half, it's going to be half of 2 centimeters, so it's going to be 1 centimeter. Okay, we've got the width. All right, now the frequency density. 15 divided by 6 is going to be 2.5. So my pen's failing me a little bit today, and this one's going to be 3. So I've got that this is 2.5. I might even write a little equals by it, 2.5. Okay, so that means that 2 centimeters is going to equal 1. And that means it's going to be 3 lots of that, 3 lots of 2 centimeters. So my height is going to be 6 centimeters. I'm just using proportion here. Be careful with it, don't rush it. These are my answers, 1 centimeter and 6 centimeters. I hope you're happy with that and I've explained it okay. Did my best anyway.